For this exercise, we are going to take a look at two different versions of method computing the Fibonacci number. So just as a reminder and to get us started, here is the Fibonacci series. So we have here the zeroth Fibonacci number, the first Fibonacci number, second, third, and fourth. So we start counting at 0. Okay, the zeroth Fibonacci number is actually 0. The first is 1, then the second is again 1, the third is 2, and the formula that we apply to get those numbers is very easy to formulate in terms of a recursive method. Okay, it's always the same thing. When you have a recursive problem to solve, generally a recursive method is the best way to model that problem, to model its solution. Okay, so we have a public static recursive method here. It's just the name of the method. And it returns an int, it takes an int, okay? So this is the basic Fibonacci implementation that is described anywhere in any textbook, any lecture, etc. So if n equals 0, right, the Fibonacci number that corresponds is 0. If we ask for the Fibonacci number 1, then it's going to be 1. And these are like the base cases that are going to stop the recursion. Now, the recursive call is here. So if we are not asked for the Fibonacci number 0 or number 1, then we are going to call our method recursively on n-1, and we are going to add the result to a recursive call on n-2. So if I'm trying to compute Fibonacci number for n equal 2, right, I'm getting the result for n equal 1 right here, and I'm getting the result for n equal 0. I'm adding them together, and I get Fibonacci number for n equal 2. So that's the recursive definition of Fibonacci. That's a recursive implementation of a method computing the nth Fibonacci number, starting with n equals 0. So what we're going to do now is we are going to try to write an iterative version of that method. So it's going to compute exactly the same thing. So the way I'm going to test those methods, in my main method here, I'm going to prompt the user to enter a value. I'm going to define a scanner first. Then I'm going to read the next integer typed by the user from that scanner. And I'm going to display the result of both computing the Fibonacci number of that value with the recursive method and the iterative method that I appropriately named iterative. Okay, so those names are just, I could have called them recursive Fibonacci, iterative Fibonacci. I don't want you to get confused. I think that, you know, all recursive method have to be named recursive and all iterative method have to be named iterative. That's not the case at all. So we're going to jump into the, well, first, before to jump into the implementation, let's compile, make sure it works. So I cheated, I pre-computed the Fibonacci value so we could test and double check easily that it's working. So the recursive version is fully implemented. The iterative version, well, it just returns whatever value you give it. So it's not going to go very far for us. So let's try to implement this iterative version. So the problem with the iterative version, and by the way, the whole point of this exercise is to show you that trying to solve iteratively a recursive problem is generally a bad idea, okay? The problem with this iterative version is that we need to keep track of two values. So at the beginning, a equals 0, b equals 1, well, these represent our two Fibonacci number. So then I can compute a new value. I'm going to call this variable new value and say that, well, I'm going to start at 0, okay? So if I call my iterative function with n equals 0, I'm not going to even start iterating. I'm just going to return new value. So the Fibonacci number 0 is 0. All right? So it makes sense with the recursive implementation. So I just mentioned that if n equals 0, I don't even want to enter my loop. So here we go. I'm going to have a loop here, start at 0, and then I lesser than n minus 1, I plus plus. Okay, so I'm trying to make the right amount of iteration here. So if n equals 0, that's going to be I equals 0, I lesser than 0 minus 1. Yeah, that's going to immediately get me out of my loop. Okay, so that's why I wrote it this way. Then the rule for Fibonacci is you add the last two numbers. So this kind of looks like what we did with the recursive function. But this is where we have to do a little bit of switcher here. We have to say that after we have computed the new value, well, A becomes, the new value of A is the current value of B. The current value of B becomes the new value. So at the end of this iteration, not only new value represents the next Fibonacci number, but we also keep shifting the values of A and B. So if you will, you know, A is here, B is here, and then at the next, A is here, B is here, and at the next iteration, well, this is going to be A, this is going to be B, and at the next one, this is going to be A, this is going to be B. So it's like the two variable A and B are sliding along that line number 5 here and taking the two consecutive values. We keep track of the two consecutive values so that as we iterate, we can always add them up to get the next one. So whereas the recursive method starts with the value n that you're looking for, and then recursively descends, you know, through that list of number, computes that list of number, the iterative version actually starts with 0 and 1, that's all we know, and then build the next Fibonacci number until we finally build, you know, as many Fibonacci numbers as you wanted to start off with. So let's try to compile this. Let's try to run it. So we're going to use the same example, right? So 10, 55, there we go. We have the same implementation here, recursive, iterative. So sometimes it's a matter of taste. In this case, you can really tell that the recursive method is much easier to read. Okay, we don't have those kind of problem of whether I stop at n or n minus 1, whether I use lesser than, lesser equal, whether I start at 1 or 0 my iteration, whether I mess up here trying to switch around the values A and B. All of those things are potential source of bugs. And if you are trying to do the exercise on your own, you are going to probably fall for one or more of those bugs, okay? The recursive version really doesn't lend itself to that bug. And again, it's not magic, it's simply that, you know, recursive problems are better solved by recursive method, and iterative problem better solved by iterative method. That's all.